I'm going to quickly go over the 3 area problems that I gave my algebra students for this weekend to finish up. And we're going to go ahead and get started with the toughest one. I suggested Heron's formula, but you can easily do this. Well, easily is a relative term. You can use Pythagorean by dividing this up into 2 triangles, and you can call that y equal -1, one of the sides, and that gives you a nice good perpendicular to work with here, and a nice good perpendicular to work with right here, if you so desired. But I thought Heron's was the most straightforward way. You could have used 1/2 AB sine C by finding the length of 2 sides and then the angle right here, but that takes a little bit of work too. So let's go ahead and take a look what I did. I pre-wrote a lot of stuff because I did want to keep this video short. So the first thing I did was I needed to find these coordinates. Well, I did a quick systems of equations, and this one obviously crosses at -3, -1, but you can always set these, the purple and the blue line equal to each other, and you're going to find that's the case. For point B right here, I went ahead and did 2/3 x plus 1 is equal to -2x plus 4. When I multiply everything by 3, I get 2x plus 3 is equal to -6x plus 12. Get that 6x to the other side. I'm going to have 8x is equal to 9. And of course, x is equal to 9/8. I do f of 9/8 into any one of my original equations here, and I will come up with 7/4. And same thing for down here. Even though I went off the graph, that's perfectly fine. I did that on purpose because several students did the same. You actually don't need the graph to do this problem. You work all coordinates through systems of equations, plug it into your distance formulas, find your semi-perimeter, and plug it into your areas. And that's exactly what I did. Look how I organized it. I did distance of AB, plugged it right in, and I used a calculator on this. So I got 11 radical 13 over 8, which is about 4.957. And this one I did in my head because the delta y and the delta x were both 11. So 121 and 121, 11 radical 2. I put this in the calculator to get a decimal answer because I figured since I'm going to go decimal on the Herons, I might as well go decimal all the way. So 15.556. Distance of BC, I did this in the calculator as well. And I did 55 radical 5 over 8, which I converted again to a decimal to be consistent. I did go to the nearest thousandths. That keeps our error down to a minimum. So if I went a little bit shorter, I can be off by 1/10 or even 2/10. Plugging it right into my Heron's formula, first I need to find the semi-perimeter, which is the sides added together divided by 2. That's all I did here. Came up with 17.93. Then I did my semi-perimeter, parentheses, semi-perimeter minus side A, semi-perimeter minus side B, semi-perimeter minus side C, plugged it all in, and came up with 37.807. Now the calculator, the Casio, does a pretty good job of knocking all this out. As you can see, I just plugged it right in. Again, to save time, I preloaded pretty much everything. And that's pretty much how you do a problem like this. Again, Heron's is just one of 4 good options. Later on, when you get into higher mathematics, you're going to learn even more ways to solve the area of a triangle. Okay, let's take a look at the next 2 real quick. These were fairly simple problems. The only thing you had to really think about is this length right here. But since this is f of 5, I just put f of 5 right here for this equation, and I get 5/2. So my delta y is going to be 5/2. My delta x is 5. So I just do 1/2 5 times 5/2. I get 25/4 as my area. Okay. Next one is a trapezoid. And these are right trapezoids because, you know, we got perpendiculars here. And so I have base 1 of 2, and again I could do f of 6 right here, but of course it's obvious it's going to turn out to be 4. So my delta y is 4 right here. My height of the trapezoid, being a right trapezoid right here, is going to be 6. I just do 1/2 2 plus 4 times 6. Well, I could cancel out that and call that a 3. That is just 6 times 3, which is 18. Alrighty, so I'm going to, I did it under 5 minutes. So I'm going to go ahead and save this and upload it to YouTube into my algebra.